Okay. Hi, everyone. My name is Haoyi, and this presentation is about better Scala builds with the Mill build tool. So for those who don't know me, I've been working in open source projects in the Scala community for almost, 13 years now. So things like Ammonite, Mill, uPickle, FastParse, Scala tags. Who's used any of these libraries from the Haoyi ecosystem? So many of you have used bits and pieces. So I've done professional work at Dropbox and Databricks, not currently working there, and I'm the author of the book, Hands-on Scala Programming. So this talk has a few sections. We'll talk about, can Scala builds be easier? We look at what the Mill build tool is, why Mill tries to improve upon those, and how does Mill work to do that. So first question is maybe like, who here thinks SBT can be better? Oh, good number of you. So I think the biggest problem with SBT is that it is not easy enough. So we know SBT is flexible. It is very flexible. It is very powerful. It can be very performant. It can parallelize things, parallelize tests, parallelize tasks. There's a REPL mode, keep the JVM warm in memory. But it's complicated. And in order to get all those benefits, it's hard. And if you don't do it correctly, it suddenly becomes slow, suddenly becomes inflexible because you can't figure it out. ID maybe doesn't help as much as you'd like. And the problem is not the power of flexibility or speed, it's just how hard it is to get all that out of your SBT build. Even in theory, you can. Scala CLI works in many cases for smaller projects, but as a project grows, you have 5 modules, 6 test suites, 2 integration test suites, and so on. Scala CLI doesn't quite support such large and complex systems. So just to dive into this a bit more, even just running SBT can be quite tricky. Like, I know a lot of people who use SBT from the command line like any other command line tool, and it doesn't work well because it's always really slow. And you need to make sure, if you do use a shell, you need to make sure you always click reload when you build definition changes. You need to make sure if you control C out of a long-running test, you need to make sure you go back in the shell. And it shouldn't be so hard to just run the damn build tool. It's not impossible, but it's non-trivial. Another thing that I looked at recently that was surprisingly difficult was parallelizing tests. There are quite a lot of configuration values around parallelizing tests, and they interact in some quite obscure ways. For example, if you turn on fork, where's fork here? I didn't include fork, but if you turn on fork in test equals true, then suddenly parallel execution test doesn't work anymore. And you go turn on a separate flag, test fork parallel equals true, or you need to override concurrent restrictions, and there are 2 different ways to override concurrent restrictions for normal tests and fork tests. And there's also fork test grouping. And in the end, it took me about 2 hours to turn on tests on the repo, and I had to ask for help on Discord because I couldn't figure it out, and ChatGPT also couldn't figure it out. And if you do it wrongly, it gets much, much slower. So test grouping is very dangerous. If you use on the right place, it gets much faster. Use on the wrong place, it gets much slower. And it's up to you to figure out which one is which. So it's tricky. Another problem with SBT is ID support. So let me just go to a live demo here. So over here, I have the Gatling code base. Gatling is a popular load testing framework. Who knows what Gatling is? Raise your hand, most of you. So IntelliJ has SVT support. Naturally, you can jump to these things, helpers. You can jump between projects. Like Gatling module has a helper here. You can see how it's defined. But a lot of things just don't work. Like, what's SVT spotless do? I don't know. Here's a face full of decompiled bytecode. Good luck. What does library dependencies do? Decompiled bytecode. So if you want to, who knows what to do next? You can shout it out. Sorry? Sources, okay. Yeah? So that's one option. The other option is you can just go to this file on GitHub. That's what I've seen suggested before. So if you go to this magic file called keys.scala in the SBT repository, you'll actually see the documentation for library dependencies. So here you are. Library dependencies is declared mod manage dependencies. And then if you try to search who's using this, again, you get nothing. So the next step is you can grab the whole SBT repo and try and figure out which one is the one that's setting your value. And this is a bit weird, right? This is not how you expect IDs to work. Like, use normal Scala code. I go back to Gatling. I go to any arbitrary, let's go to arbitrary application code file. I expect to jump to any single identifier in this entire file, and it doesn't matter whether it's local, third-party, standard library, Java, Scala library, it should just work and bring me there. But SVT, it doesn't. You get these stubs. You go to the website, get stubs. You end up searching the entire code base. So that's that part of the problem. And The extensibility can be quite tricky. Like SVT has a huge number of plugins, that's good. SVT needs a huge number of plugins to do anything, that's bad. So if you want to set up a project with run JUnit tests using the most popular test suite in a JVM, I want to auto-format my code as well. Suddenly I end up doing this grand tour of the Scala open source ecosystem to build this Avengers team of plugins, all of varying maintenance levels and quality in order to try and do what you want. And it can be done. As I said, SVT is very flexible, but it's hard. So I guess the last thing is even doing simple things like, let's say I have this custom task that I want to implement, count lines of code and save in a resource file. It's quite tricky to do it right. You give this to a new grad, they won't be able to do it unless they spend hours poring over SVT documentation and fiddling within the terminal. And it's not impossible. It can be done. I've done it here. But this is a totally trivial thing that should take 30 seconds to implement. Like, it should be easy. It should be totally straightforward. And yet, SVT, it is not straightforward. It's not impossible, but it can be tricky. So that's where I think it can be easier. Next, let's look at what is Mill. So Mill is an open source build tool, originally for Scala, started in 2017. It's been around a while. Now supports Java, Kotlin, and also supports other languages more experimentally, Python, JavaScript, Android platform. And it doesn't do anything magic, but just aims to be faster, easier to use and extend than the existing build tools. It's quite widely used, so Corsair you all use indirectly through Scala CLI, and or Bazel uses Corsair, or SVT uses Corsair. Scala CLI itself. A lot of the Scala hardware design space is on Mill for some reason, so Chisel, Spinal HDL, and of course all of my projects, Ammonite, OSLib, FastPass, all on Mill for many years. I've not touched SVT since 2016 or so, and it's been great, I can tell you that. So the documentation's here, and let's move on. So Mill Hello World looks like this. You have an object, full extend Scala module, you have some defs. This egg thing is basically a special kind of sequence. It's going to become a normal sequence in the next major version. For now, it's still here. You define the normal keys like Scala version, dependencies, tests out, test uses another object with superclass dependencies. And you can compile, run, test, assemble, so on. So this is just a high-level look at what it looks like in Mill. You can do more sophisticated things, like here's a to-do MVC HTTP4S web server. HTTP4S has more dependencies than Hello World, but it works. So if I go back to my demo, go HTTP4S, go Mill, what was the name? Run background, -- watch. I can go to localhost 8084 and see the Hello World here. So that's kind of nice. This is an interactive, standard Hello to-do MVC application. Because I use -- watch, if I open up the source code, which is over here, let's say I move this here. If I change this to like to-dos Hello World, you'll see automatically picks it up instantly and reloads, and here we are. It's to-dos Hello World. It's a bit verbose, it's a bit cluttered. If I want to change the default tasks, let's say instead of profit, I want to say like amortized losses. I can't spell. Okay, amortized losses. No profits this quarter, and it automatically updates once HTTP4S starts again. And yeah, this is all HTTP4S code, and it runs just fine in Mill. So people often ask, what does Mill support? And the answer is, by default, basically everything on the JVM you'd want to do using SVT or Maven or Gradle, you can probably do using Mill. There's some asterisks here, like we don't have good support for Kotlin native and multi-platform. We don't have that great support for Android. Scala, but in terms of Java, Scala, and all the core stuff, and including things like Scala.js, Scala native, all the different publishing and destinations, it generally just works. All the different test suites, packaging formats, and so on. So that's what Mill is. So why Mill? There are basically three reasons here, and then it tries to fix the problems we saw with SVT earlier. For example, performance. For example, you look at the Gatling code base again. This is our benchmark. We ported the build over from SVT to Mill. Took about 3 hours to do manually. It wasn't terribly complicated. Nowadays, you have an auto importer to make it even faster. And it's 80K lines of code, 20 sub-projects. Test pass in both SVT and Mill. It's more or less complete port. And you look at the numbers, what you realize is SVT really has two performance profiles if used cold and if used hot. And as we saw earlier, if it's used hot, it's kind of tricky to make sure you reload and Control-C and get back in at the right times, but you get good performance. If you use cold like you would any other command line tool, you get awful performance. Mill, you use code like a command line tool, and you get decent performance. And it's not because Mill does anything special. Mill just does all this reloading and restarting for you. So Mill has a background server. You type command line tools mill foo. If there's no background server, it'll start one. If it dies, it'll start it again. If the build config changes, it will notice and it'll reload the config for you. Like, this isn't rocket science here, but Mill just does it for you, so you don't need to do it while you're programming. There's a lot of other interesting things. For example, earlier we mentioned, we already saw watch and rerun. This is very convenient, works very well in Mill, including for build level changes, resource changes, and so on. Test parallelism in Mill generally is quite self-tuning. You just turn on test parallelism, and it does a somewhat intelligent thing, trying to minimize the number of JVMs you spawn on maximizing parallelism, including depending on how fast your tests run and how many modules you have, it tries to optimize. And even for whether you have many small tests or a few big tests, it does a decent job. Not perfect, but pretty good, and you don't need to fiddle with it. Selective test execution. If I make a change, for example, one test module suite here, I can do git checkout selective.prepare, check out the branch, and I can kind of ask Mill, what test changed in this folder? For example wildcard tests, which of those tasks were affected by my code change? I can get the list of tasks. I can get the task tree of who affected who. So the test repo source root was changed, therefore it affects test repo root, therefore affects resources, therefore affects the test target. And I can run it, and it will therefore only run that one test rather than running every single test, including the ones which are mostly unrelated. Very good in CI, where you want to speed things up, and you often only change small parts of your code base. Incremental assemblies. If you use Spark Submit, if you make big assemblies for deployment, Mill builds them incrementally. So everyone builds the same big assemblies about the same amount of time, 20-ish seconds with some variation depending on your luck. But Mill, the second time you build it, is much faster because building a big assembly is slow, but most people don't know that assemblies like are zip files, and zip files like Docker containers can be layered. So you can build a zip file, copy it, and then quite efficiently update that zip file and copy it again, and quite efficiently update it again. So when you change your application code, we can use a previously built assembly with all the big, expensive third-party dependencies, copy it, update your new application code, and ship it. So it takes 1 second instead of 20 seconds to build a big Spark Submit assembly jar, which is also very inconvenient when you're iterating on like Spark Submit. The Chrome profiler. So Mill comes with a built-in profiler, and let me go back to Gatling, and let's run _compile. So double underscore compile is like wildcard compile. It's going to compile everything. Okay, I already did it, so it was fast. Let me clean it and then compile everything again. Okay, so now it'll take a moment. So most people don't realize that everyone in this room already has a profile visualization UI built into Chrome. You go into Chrome://tracing, it's here. And anyone in this room who wants to profile something and visualize it in a useful way can use this UI. So if I pull up this Gatling folder that's currently running, it's still running, but never mind, I can do it already. It generates this Chrome profile Mill Chrome profile JSON file. So this is a standard format that Chrome publishes that you can integrate with. And just load it into your, sorry, where did it run away to? Not you. You, okay. Just load it into your Chrome browser, and you can see, even before the task is completed, where is my time going. So you can see here it's bottlenecked on Gatling core compile. Here are these fellows on the right were bottlenecked on Gatling core test compile. Different threads running at the same time taken on the wall clock. You can see exactly where my 25 seconds or 27 seconds have gone so far, even before the job completed or command completed. And you can already have some ideas of what you want to do to optimize it. Like, can we split core to move all this stuff to the left? Does Gatling recorder test really need a whole core test suite to compile before it starts running, or can it depend on some subset utils file? And that would move all this stuff to the left, and that would allow the wall clock to finish faster. So again, this is something that every build tool has to some degree of difficulty. So SVT can probably find a plugin to do it for you and integrate it, and you're not going to do it because it's too troublesome. With Gradle, you can go pay for Gradle Enterprise, download the Gradle Enterprise self-hosted web server, set it up, and upload your build scan to Gradle Enterprise and get this visualization. In Mill, you get a JSON file, you load into your browser, and you're done. You can see where your time is going in your build. And even before that, right? Like if I clean here, and you run core compile, you can see all the things that are running, similar to SVT Gradle and so on. So that's quite nice. Let me see. Okay, next point is IDE support. So earlier we mentioned that SVT IDE support exists, perhaps not ideal. Let's look at Mill. So over here, I have the SVT and Mill build for the Gatling project right next to each other. So Gatling core. So you'll see that the two projects, the config is actually not that different. The spelling is a bit different. Yeah, one is object, one is lazy val, one is depends on, one is module depth, but it's the same meaning. Like, Mill doesn't do magic, it still needs to configure the project to build in the same way, and we need to do that. So where things are different is when you jump to, for example, IV depth in Mill, IntelliJ knows that IV depth is an overridden method because it's just normal Scala. IntelliJ knows Scala, knows it's overridden, knows it's overridden from Java module or Java module base. It knows it can jump to the overridden methods, that's what IntelliJ does, including with sources and Scala doc. I don't know why all the other build tools can't do this for some reason, but in Mill you can. You can search for things like IV depth, where is it used? IV depth is used in all IV depths. Let's see where else it's used. Okay, it's used in this very big like Corsair project thing. It's used to set up the Corsair project. Corsair project is used in transitive Corsair projects. And you can see that you can transitively kind of understand your build just like what you do in application code. So of course, you could always go to GitHub and grab the source code that you do with SVT. You could go search the documentation, hope it tells you what to do, just like you do with SVT or Gradle or Maven. But with Mill, you have one more option, which is what you're already doing every day. You go jump to definition, jump to definition, jump to definition, find usages, find usages, find usages, and you will find what you want. And everything like autocomplete works as well. So you want to see what task I can override here. You can say override def, and it should spin up. It is not spinning up, I'm not sure. Have to ask the IntelliJ folks why this doesn't work. It's meant to work. Let's try again later. Maybe it'll work better in 5 minutes. So yeah, that's an understandability. The IDE actually works in Mill just as well as it does with any Scala project, which is not perfect, but it is much better than works with SVT, Gradle, Maven, or most other build tools. Last, extensibility. The first thing we realized in Mill is that we put in a lot of effort to just bundle a lot more stuff. So like we just provide the JUnit interface. It's not that complicated. We have our own JMH bundled. We have our own packaging assembly. If you want to build assembly you can run later, you don't need a separate plugin. Of course, everyone wants to build things you can run later outside of a build tool, so Mill provides it. There are plugins, like ScalaFix in this case is still a third-party plugin. You still need to grab it from a separate person's Maven Central account. But generally, you can get quite a lot done with Mill without having to first go on a grand tour of the Scala open source plugin ecosystem. Next interesting thing is that if you don't want to use plugins, you want to just customize the project yourself or build yourself. It is much easier in Mill than in SVT or other build tools. You just write code and use libraries, and I'll show that to you now. So let's go back to IntelliJ. Custom Java. No, this is not the one I want. I want custom Scala. Let's pull that up. Recent projects, custom Scala. Okay. Pray to the IntelliJ gods that this works. Go here in the terminal. Okay, so here's a kind of minimal build file for Scala. You can see it is very minimal. There's not much here. And yeah, Mill has the same defaults as SVT or Maven or Gradle, all your standard source locations, standard resource folder, so on. You can customize it. There are a few different defaults you can choose, but if you don't have a particular preference, there's not much to customize. So I can compile this code, mill foo.compile, and here it works. So let's say I have the same requirement as just now. I want to save the line count of the project as a text file. So let's have, in Mill, the way you do this is you define method line count, which is a task. I can refer to other tasks, such as foo.one of the source file tasks, right? There are a bunch of them, but I have documentation for each of them, so I can pull it up and see what do I want to call here. You can't do this with SVT, right? Like I can say I want all sources, but this is the folders. I want all source files, which is individual files. You can see I can map them. So f goes f.path to get the path of that file. I can use os.read_lines to count the lines. For those of you who know oslib, this is the same oslib, nothing special, size or length. .sum. And I can have some Scala doc, right? Like lines of code in this module. So now this is all I need to do to define a task. In the terminal, I can do mill show foo.line count. It needs to recompile the Scala, which is slow. But okay, it's print 17. I can show mill inspect foo.line count. You can see it says foo.line count is in build.mill line 8. Here's a Scala doc that we actually conveniently capture for you, so you don't need to go duplicate in some string somewhere. And you can see the inputs are foo.all source files, which we also capture for you, so you don't need to go and write it out yourself somewhere. You just say, oh, foo.all source files, and we capture that method called dependency, so that we know that there's a task dependency. So if I want to add the resource file, I can override def resources. And yes, now IntelliJ is happy. So override def resources. Again, you can see there are multiple resource tasks you can override. You can read the Scala doc for each one, choose the one you want. In this case, I want this one as a task. I can write to the destination folder of each of the task to line count.txt. I want to write line count as a string. And I want to append to the resource path. You know, Java, class path, resource path can have multiple folders. I'm going to append the path reference to its task.destination folder. So this is worth explaining a bit. Task.dest, every task in Mill gets a separate destination folder. They are all unique. For example, foo resources gets foo/resources.dest as a folder. And it's very convenient because you can write stuff to that folder without worrying about conflicts with other tasks at all. So it basically turns your file system from shared mutable state to non-shared mutable state, right? It's now kind of isolated mutable state. And you can almost treat your files that you're writing out as pure functional values because no one else can mutate them, no one else can delete them, overwrite them. You can't accidentally depend on someone else's mutable state. You return the reference to the file, and it's an immutable file value. Very convenient. Now I've overridden resources. I can show foo.resources. You'll see that it has now two resource paths. That has the foo/resources folder. That's a normal one. And in the out folder has a foo/resources.dest. That's the destination folder I mentioned. In here, you can see line count.txt. And if I cat that out, you can see the value. And if I do foo.run, you'll see at runtime, I'm able to access the line count and print it out at runtime as a runtime resource. So great, like you all know Scala. Hopefully this Scala looks like the Scala you're already used to knowing. There's a bit of unusual stuff, like there's this task block here, task.dest. But by and large, it's very normal Scala, including things like os.read.lines, .map.sum. You already know that. You already know what override and super do. I don't need to explain it to you. Like you learned that in Java 101 15 years ago, and you still know today, hopefully. So let's extend this example a bit. Let's say I want to render some HTML. So Mill doesn't come bundled with the HTML rendering engine, but you can import one. So you can import $iv com.li Scala Scala tags Let me just see what version I should use in the demo. Sorry, one moment here. I'm using Scala tags 0.12.0. 0.12.0, then import Scala tags.text.all.star. So you see it doesn't work now. If I reload the IntelliJ, it should take a second or two. And it will start working. Yep, so now I can jump to Scala tags in my IDE. IntelliJ knows that it's here. You can jump to it and explore it just like I can explore any third-party Scala library. And now I can just define a new method. HTML snippet is a task, which is h1 of the line count as a string. .render. And instead of using line count.txt as the raw string, I can do HTML snippet, just a value. Now if I run foo.run, you'll see that I have the HTML rendered at build time. So this is a very contrived example. No one actually wants to render line count HTML pages at build time. But people do all sorts of things at build time that need custom logic, and not only custom logic, but third-party libraries, because you all are JVM developers, use Maven Central heavily, and you want, if you have some IDL library, code generation library, you have some special linter that some team is trying to prototype and try, but the other teams don't want to try yet, so there's no plugin for it. But in Mill, it doesn't matter that there's no plugin for it, because it's very easy to customize the code yourself. And as I have shown here in the last 4 minutes, just writing this out, And it generally just does what you'd expect, including with full caching, parallelism, and all that, and with no collisions on the file system because every task gets its own destination folder. So all those things that are very error-prone in the build become very easy in Mill, and just focus on the business logic and extend the code to do exactly what you want using whatever libraries you want without needing to be beholden to third-party plugin authors. So I'm going to skip this part. So I guess the last part we're going to talk about is how does Mill work, or how does Mill provide this? So there are a few ideas here. One is that build graphs are pure functional programs. Every build step is do thing to input to make output. In Mill, it's spelled def output equals task do thing input 1, input 2, but it's the same idea. It's a pure function. You call it input to provide the output. Resolving dependencies to make jars, running code gen and IDLs to make source files, compiling source files and dependencies to make class files. They all do things to inputs to make outputs. They're all pure functions. And what can you do with pure functions? You can cache them, you can parallelize them, you can incrementally recompute them only where necessary. And Mill takes full advantage of that. So every task in Mill only reads its inputs, only returns its outputs. There's a star there. The outputs can be files on disk, but if you write the files into your destination folder, there's no side effects because no one else can touch them unless you return them. And there's no more side effects, no mutation of global state. No one's just scribbling over your target folder and hoping that no one else collides. Task outputs are immutable. That's also important. And that is also the reason why jump to definition tells you everything you know about the task. Like everyone here has used Java where you jump to definition, you get a getter and setter. Then who's setting it? I don't know. Anyone could be setting it. You look at code base at 500 call sites for the setter, you don't know who's setting it. But with the immutable value, jump to definition, you get the computation of that value there. So for example, in SBT, you jump to unmanaged source directories, you basically get a stub. Doesn't tell you anything about what the computation. In Mill, you have all source files. You jump, you get find source files. You jump to all sources, you get sources plus generate sources. You jump to sources, you get this. You can jump to find source files, you get the definition. Because Mill does the build logic in a functional way, it actually makes the IDE experience superior to what you see in like a Java code base, where you often jump to like stubs or mutable variables, which don't tell you as much as you would like. That's the first idea. In Mill, build graphs are pure functional programs. Next, modules are objects and tasks are methods. So when you say object foo extends Java module here, this isn't some special syntax. It's literally a Scala object with the Java module abstract class or trait. It inherits methods just like any other object inherits from its superclasses. In this case, I slightly simplified it. So let's say sources gets used by compile, gets used by class path, gets used by assembly, which also uses resources. And this method call graph in Mill is the task graph or the build graph. So you don't have a separate step of constructing the graph mutably using after running your code. You define your code, and that is the graph that you will be using at build time. So when I say def line count equals all source files do something, and I say override def resources equals super.resources plus something, you already know how override and super work. You already know how method calls and calling and defining new methods work. So you know how the method call graph change as a result of these definitions. I don't need to teach you. And so once I have this graph, Mill can do interesting things like I know that compile and line count can run on separate threads. They don't depend on each other. But assembly must run after both. You can do interesting things like every task, foo.linecount can get a linecount.json file to put its cache on. And I can cache it for you, so you don't need to do it yourself. Foo.compile is not just JSON, right? Compile has files, so it has a destination folder we mentioned earlier, and any metadata goes in JSON. And same with assembly. I can incrementally recompute things for you. I touch the resource folder, which is now super.resources because you overrode it. Mill knows that I need to recompute resources, I need to recompute assembly, but I do not need to recompute line count and compile because it's not downstream of my change. So what's most interesting here is that there's no code-related parallelism or caching or anything here. It's all just business logic, and Mill will handle all the rest for you. And that's why Mill is quite easy to understand, even though it's code. It's not metadata, it's code, but it's very easy code without a lot of the complexity you see in SVT or Gradle. So the last idea I'm going to look at, I have 40 seconds left, is Mill uses a direct style DSL. You pull up the term direct style Scala. You look at left and the right, they're both Scala. Which Scala looks like the Scala you write every day? Like do you use lazy vals with keys and colon equals every day, or do you use objects and extends and defs every day? You use objects and extends and defs every day, right? You know how that stuff works. You don't know the stuff on the right, even though it's technically Scala. And so the way you look at it is that SBT is really two programs. There's a Scala program you run, which is in green here. It's nice stuff IntelliJ understands. And there's the red stuff that you don't understand, and IntelliJ doesn't understand, but it's very important in SBT to define logic. Like, do you know how the four-dimensional hypermatrix tesseract works? No, okay, yeah. But you know how lexical scoping works, and that's important. So Mill pushes very hard to squeeze it all into Scala syntax. So Scala doc are doc strings, like methods are tasks, objects are modules. You know how those things work. The call graph is your build graph. So all of these things not only make it easy for developer, which all of you who already know Scala, you already know how these things work. It also makes it very easy for the IntelliJ IDE or VS Code IDE to understand, because VS Code understands Scala. Well, this is Scala, so it can navigate around the build graph just like it navigates around the task graph, the method call graph of any application code base. So that's the last thing about how Mill works, these three core ideas. So the core idea for this talk, I guess, is that Scala builds, I think, can be easier than they are today. The big problem is not power, but ease of use. And Mill tries to improve upon all those use cases. It's not more performant than SBT views ideally. It's not more flexible if used ideally. But it's much easier to use in a somewhat ideal fashion. And it uses a lot of these ideas from Scala, which are very important to make the build work, like pure functions, objects, methods, hybrid of object-oriented pure function stuff. That is very important to make Mill work and provide the experience it does today. So the docs are here, GitHub repo is here. There's a issue bounty program. I think there's a few $1,000 USD there for people who want to help out. And I guess I can now take questions if there's time. Thank you.